Hi viewers, welcome to today's episode of Ulari Online Maths class. In today's video, we'll be finding the derivative of y equals exponential 2x sine x over x. So as promised, I said I will be making a video on how to differentiate a function that involves the whole, or should I say the three rules of differentiation I've taught already, right? So for this one, you can see we have exponential, which is e power 2x sine x over x. This question looks complex, but trust me, it's very direct. So the first thing you have to do is, if you observe very well, the numerator has two functions being product of themselves, right? So, but we have one function under, isn't it? So what you have to do is, the first thing is, let's write solution, right? So the first thing you have to do is differentiate what you have in the numerator, because look at this, you can say let u is equals, you're having exponential 2x sine x, right? This is going to be your u. That's if you want to start by talking about the quotient rule, because if the quotient rule is in the form y is u over v, the whole term in the numerator to be my u, then the term in the denominator to be my v, right? So looking at this and comparing with the question we have here, we have our u to be exponential 2x sine x, right? Then our v to be v right now is going to be x. But the thing is, in the formula for the quotient rule, which is dy dx equals v du dx minus u dv dx. If you want to use this formula, sorry, this is over v squared. If you want to use this formula, uh we need du, isn't it? Because look at, we have du here. So how do we resolve for our du? You can see that we still have another thing that need to be differentiated in a complex way, right? So I've not taught you guys how to differentiate exponential functions, but I will just brief it now. Because if you differentiate, when you have y equals exponential x, right? If you differentiate this function, the y dx of exponential x is always exponential x. No matter the number of times you differentiate exponential x, it will continue repeating itself, right? So, but when you have it power, let's say, let me make it ax. I don't want to call any number for now. I want to give it generality to it. I want to give it that. So our dy, sorry, I should write it here. Dy dx, right, is equals, this is exponential ax, right? So dy dx of such a function is going to be, you differentiate the power, which is ax. If you differentiate ax with respect to x, right? When you have ax, if you are to differentiate, recall what I said, is just to bring the coefficient, right? The coefficient of x here is what? A. So that means dy dx of ax is going to be a. So if you differentiate the numerator, ax, the derivative is a. You write it, right? You multiply by, bring back the function, e raised to power ax. So it's going to be a e power ax. So what if, so assuming it is y equals e 2x now, let's use the same method. It's just to differentiate 2x. If you differentiate 2x, you are going to have what? 2, then exponential what? 2x, which is exactly what I said here. If you are to differentiate this successively, that's to say you differentiate it more than once, let's say n times, is going to just have a power n, then e power ax, right? So let's say you want to redifferentiate again. Let's say sorry, this is the x squared, which is going to be what? We are differentiating twice, so it's going to be a squared, because a will still come down and meet this, a squared exponential ax. If you differentiate for the third time, let's say the 3y the x squared, this is going to be a cube exponential ax. That was why I said a power n exponential ax is the generality of such. We have exponential ax, then the n of y, the xn, that's the nth derivative, is going to be a power n exponential ax, where n is just the number of times you want to differentiate it. So if you just substitute this in the formula, you're going to have what you need, right? So let's come back to this. So if you want to differentiate this now, exponential 2x, normally you're supposed to use your chain rule and the rest, right? But now I just want to do a shortcut to this, so it will reduce our work. So du dx already, you can see that du dx, to get du dx is still going to be a product rule, right? So what we have to do here is, I'll teach you guys a shortcut. The shortcut I'm talking about is, I'll keep the first function because it's a product rule, right? Keep the first function, which is exponential 2x, multiply by derivative of the second function, which is sine x. If you differentiate sine x, you're going to have cos x, right? Then plus, keep the second function, sine x, right? Multiply by the derivative of the first function. So the derivative of exponential 2x, I think I've done it already. The derivative is going to be 2 exponential 2x. So this is going to be multiplying itself by exponential 2x, right? So du dx is going to be, let's rearrange things. This is exponential 2x cos x plus 2 exponential 2x sine x. You can see we have exponential, we have exponential. That means we can factor it out, right? So this is going to be exponential 2x, open bracket. We are going to have cos x plus sine x, right? So this is it. Since we've gotten du dx, the next thing is to find our dv dx, right? So dv dx is going to be 1, right? Dv dx is what? 1, because v is what? X. So derivative of x is what? 1. So we have everything. The next thing is to just substitute in the formula. So let's manage this space. I pray it takes the whole thing. So let's substitute. If I want to use the quotient rule, which is dy dx equals, I've written it somewhere, okay? So this is v du dx minus u dv dx, everything over v squared. So this is equals, if you substitute v, what is v? We said v was x, right? So this is x multiplied by, if you substitute du dx, what is du dx? We said is the whole of this, right? Open the bracket, exponential 2x, open a bracket, right? I want to substitute this, cos x plus what? Sine x, close bracket, right? So this is, I'm done with this portion. This is minus, what is u? We said u is exponential 2x multiplied by sine x, right? Sine x, then everything over v squared. And our v is what? X. So x squared. Let's rearrange things here, then we leave the function as it is. I can just say this is x exponential 2x, then the whole of the function here, cos x plus sine x, then minus exponential 2x sine x. If you like, you can factor out exponential 2x again and continue, but no need to do the whole of that, because sometimes reducing the, if you differentiate a function, if you want to reduce it to the end, you're seriously going to suffer yourself, right? Since substituting the value of x will just tell me what I need or no need, right? So that is it. That's how to differentiate a function that is having the whole of the rules we've discussed already. So thanks for watching. I hope you enjoyed the video. If you really do, I just hope and pray you comment, you like, share, and subscribe to the channel. Thank you.